For the final layer of our ink compositing, we're going to create an additional element, more or less like very tiny bubbles, or it could be debris on the water tank. And for that, we're going to use a relatively simple particle system. So let's go ahead and create a new geometry node. This time, let's call these bubbles. Let's dive in and let's create a box. Make sure it's big enough to cover the entire view. So I'm going to make it 2 meters wide, 2 meters high, and 1 meter in depth is okay. So if you zoom out, you'll notice that the box is covering most of the scene, or at least what's going to be seen through the camera. So now let's lay down a VDB from polygons. And make sure that under the properties for this node, turn off distance VDB and turn on fog VDB. So we need the density to scatter some points. So let's lay down the scatter node, connect it to the VDB from polygons. And notice we have a fair amount of particles now. So let's see through the camera. I'll probably increase the particle count. So remember, we can always decide in the end to delete some of these particles. So I personally rather have more than less. And that's basically all we need as an emitter. So let's now create a pop network. Let's connect it below the scatter node. And what I usually like to do is change its color, also its name. So I'll call it pop bubbles. Now let's go back to frame 1. Let's dive into the pop network. And let's take a look at the pop source. So by default, remember we have the scatter onto surfaces option. Currently we don't have surfaces, so we can either use all points, or in this case we can also use all geometry. Since we only have points, that would be enough to make this work. Now let's take a look at the birth parameters. One very important thing is we only want to generate these particles on the very first simulation frame. For that, I'm going to use a very simple function. I'm going to type $SF, which means simulation frame, equals 1. So basically with this, the particles will be emitted only on the very first simulation frame. So let's create some space here. One thing I mentioned before is I usually like to add a mass attribute for the particles. So type pop properties to lay down a node. So we've done this before. Make sure to call this node set mass. Turn on the mass attribute and scroll down to turn on use the expression. So remember, we can randomize the mass attribute by clicking here on this arrow button and then selecting this first option, randomize mass. Now to increase the difference in mass, I will decrease this first value. I'll change it to 0.2. And now we're going to simulate the buoyancy, adding a pop force to push these particles upward, but only a tiny bit. So let's drop down a pop force. Let's connect it to the mainstream and let's call this buoyancy. Now let's increase the force in Y to 0.002 and let's take a look what we have so far. So this is fine. They're rising very slowly. One thing that I cannot see is the difference between the speeds of the particles. And this is because the ignore mass is on by default on all these forces. So make sure to turn this option off. So again, let's go back to frame 1 and let's add another pop force. This time we're going to add some turbulence. So let's call this one add turbulence. Again, make sure to turn off ignore mass. And the amplitude will be very low. Let's use 0.01. I will also decrease the swirl size to 0.2. And let's press play, see what we have. Okay, so this is too much. The amplitude is currently extremely high, so let's go with 0.02. And this is looking much better. I would probably even decrease the buoyancy. So let's go back to our buoyancy and change the value to 0.005. And I think this is working better. So one final thing that I want to do is, besides this turbulence, I want to add a very low frequency turbulence to make the bubbles sway from left to right, but with a very small amplitude. So let's add another pop force. Let's call this one add turbulence small. And as I mentioned before, I want the amplitude to be very small. So let's change the swirl size to 0.01. The amplitude should be very low as well. So I'll use 0.001. And if I scroll down, I'll find the pulse length. So if I increase this value, the speed of the swaying will be higher. So the lower this value is, the slower they will move. So let's take a look at this. I think it's working. You can always change the values as you see fit. But for now, let's go ahead and start caching these particles. So let's go back to the geometry node. Let's now add a .io node. And make sure to drag your pop network here under the pop network property. And for the DOP node, we can dive inside the network, look for our pop object, and copy this node. Go back to our .io and paste it here under the DOP node. One more thing we need to do is change the preset to particles. Okay, so we're ready to cache the particles. Let's add a ROP geometry output. Let's connect it to our .io. And let's change the name of this node to bubbles. Let's now change the valid frame range to render frame range. And as usual, let's change the name of the resulting file. I will save the file in the geo folder. Now I will use the $OS variable to create a folder with the name of our node, then slash, and the name of the file is fine, $OS, $F, you can add a padding of 4 if you want, and .bgeo.sc is fine. So make sure to save your particles to disk, and I'll be back in a moment.